Welcome everybody. To those who I have not said hello to, I think we've got a cast of characters here tonight. Good showing. This is our June AF Mixer meeting. Please note that all of our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood and assumed that you are in agreement with this recording and have accepted the terms. So tonight we have a few items on the agenda. Two of them are from our esteemed colleague Peter, VE3POA. He's got two topics that he's talking about. One of them, which is his own audio analyzer project that he is going to tell us about, as well as going over, I guess, a cool chip segment, possibly the type that Kevin does with his overview of interesting chips that might feature in a upcoming project of yours, especially after you hear about it. So I'm also going to briefly touch on Field Day. I'm hosting it again here at the farm for those of you that are interested in bringing their bits and bobs to our place here and operating. So we'll talk about that after as well. Does anybody have any agenda items that they'd like to bring to the table?
You doing the round table?
We'll do a round table, time permitting, I would think. What are your topics relatively brief, Peter?
Yes.
Yep. Okay. All right. So yeah, I think with that, by the way, we were discussing about trying out a Google Meet session at the end of this meeting, but turns out that the package that Charlie has access to, that he was willing to have us use, does not have the recording feature on it. So the nonprofit tier that doesn't cost anything does not include recording. Unfortunately, we thought it did initially, but turns out that it doesn't. So we're back in the same boat. It's about $200 odd a year for, seems, whatever platform you use, be it Zoom, Meet, or otherwise, to get all the features that we use here for no charge on Jitsi, which is basically unlimited meeting length and recording feature. Those are really the two things we need, plus a platform that works. So anyway, so that's a no-go for this evening, but we'll be kicking around some ideas to see if we can improve our performance on the meeting here. So Ken, go ahead.
Yeah, I was doing some testing over the weekend. The closest spot to my modem is in the family room, and I did a Cat 5 cable to my laptop, and I've been using it all week. I just wanted to see if there was any issues. So far, so good. So now I'm going to try and figure a way of running a Cat 5 cable to the front living room where my work desk is. So hopefully this week I can have it figured out and do some testing there. Especially with work, I want to make sure it doesn't screw things up for work. And I could probably do a test recording. Question: if I did a test recording over the weekend, say for an hour, would everybody be willing to just pop in, wave to the camera, and then just go off and do something, and then save the recording and I'll check and see what happens?
Or what you could do, actually, Ken, is just whatever, I can just log in and I can have my whatever office here just in the background, and you can do your recording, right? So if that works for you, right? I mean, I've done that kind of test before where I've just been the only person, or I have two computers that are logged in, and then I just whatever record not locally, but two users logged into the same meeting, and that seems to work as a test. It consumes the same amount of bandwidth in my monitoring and all that. So just so you know.
Okay. I'm going to try it on the weekend anyway, so I'll let you guys know.
Yeah. Okay, Dave?
Yeah, I'm just curious, what's the purpose of that? Having one recording and having one person come in. What is that gonna do? I'm just curious.
That's a question for you, Ken, I believe, right? You're muted.
Oh, I don't know if the question's for me, but I'd like a few faces in the recording. I think there's more stress with this amount of people on a session than there is for a background recording with one person in it.
Perhaps, yeah. I thought you were testing your local connection,
Well, yeah, I'm testing the connection, but I also like to test the recording as well, and watch the network connection in the task manager.
Yeah. Okay. All right. Well, whatever. Just offering that as a suggestion. Now, one data point I can offer here as well is I've actually started up an advanced qualification course with the York Region Club. First real meeting was this past Monday. They used Google Meets as the platform, and it was solid here. I had no dropouts during the presentation. There was one moment where, when it was just talking head, the presenter, it actually said video is paused for bandwidth issue. It happened once in the 2 hours, briefly, but other than that, it was flawless. So I don't know what we can gain from that, other than maybe Meet is a more robust platform. Beyond that, that's just an FYI. So. Okay, anyway, well, let's get on with the matters at hand here. So, Peter, if you're ready to, I'm sure you're more than ready to rock and roll.
Well, I don't know about that.
Wow, and the first thing I get is Peter's screen has been turned off to save bandwidth.
You're kidding.
As soon as you push the buttons. Okay, but it just popped up. It's going off and on the recording.
Is everybody else okay?
Yeah, I'm not seeing anything like that, Peter, but looks
Works for me.
Okay.
It's working fine.
All right.
Does maybe somebody else want to do the recording? I don't know if it's too late for that, but
Anyway, we'll get started and we'll see what happens. Anyway, this all kind of came about when I was thinking about taking a look at audio signals, and the SA wouldn't do it, and I wasn't sure about the FFT on the scope, and I also was in the kind of mood to build something and use some parts that have been lying around in the shack doing nothing for a long time. So I picked up. I think I read an article too that talked about it, so I kind of put it all together and came up with this. So quite simple. This here on the left is obviously is the schematic. There's nothing much to it. There's the ST7920 screen, and then the Arduino Nano, and voltage divider there, and that's about it. Contrast control. There's the circuit board layout. I thought pretty easy layout. Thought I had it down pat, worked great. Got it back. I realized I had it flipped. The U1 connector was flipped. So, but the fix was easy. So instead of putting the screen on the other side of the board where it wouldn't interfere with RV1, I now had to put the screen on the top of the board, so that covered over RV1. But in reality, not a big deal. So just some key points on it. And again, I put this together quite several months ago, so I may have forgotten some of the little finer details with this, but it's not that difficult of a project. Samples 128 points of audio on the input. I found a library that's called fix_FFT. that does all the heavy lifting. Magnitudes are scaled within software gain to help things out a little bit, and their max levels are capped off. And it can be out displayed as a bar graph on the LCD screen. And the frequency of interest in this particular case was 0 to 4 kilohertz. Remember, I'm using a nano. And there was some debugging code in there for the serial monitor at the beginning as well. If I wanted to go to more than 4 kilohertz, you'd have to switch the processor. The flow diagram, pretty simple, straightforward. Audio in, that feeds directly into the ADC, and then the library for the FFT does its magic. And then we do a little bit of software stuff with the scaling with the magnitude and whatnot, and then do some bin stuff, combining the bins with data reduction, and then display it off into the LCD. And that's about it. So here's what the screen looks like, and we'll just play. We've got a few seconds here of it in action. So you can far more pronounced than the, but it is picking up things all the way up the top end to 4 kilohertz. And there was a little bit of effort put in it to get it to at least this point, and most of it had to do with the scaling of things. But it was enough to do, I guess, really a proof of concept to say, you know, this can work. And if you can do something like this with the nano, I'm sure you can do things much better with a much better processor. And again, back when I put this together, I kind of threw this together in there, and it's somewhat changed now, of course. Audio spectrum analyzer, well, yeah, sure, that's what it's all about. Filter testing, yeah, I guess you can do some of that as well. What's nice, of course, with something like this is observe the frequency responses. It changes in real time. And I guess, Michael, when we were talking about, you know, your audio board and the tone control and all that kind of stuff, it would have been quite handy to have something like this to watch what was going on while Michael was doing the changes to the tone controls in the audio board he did for the backplane radio. I threw IF monitoring in here for some reason, and I have no idea why I did that, because it doesn't make sense because of the frequencies. But anyway, for whatever reason, it's there. Upgrade pass, well, increase the samples for higher frequency resolution. Maybe use an external ADC for better speed accuracy. Now that I think of it, I'm not sure that would work, but who knows. Preamp, again, not sure where my head was on that one. I'm not 100% sure that would work either, but you never know until you try it. Replace the ST7920 with a color TFT. Yeah, more details for that would be kind of nice. But then again, now you're moving things up into the dollars. So I would think before I do something like that, I'd want to have something that's well, really works really well. Short-term improvements using the nano, if one was so inclined to do so, because I think really that if I was going to pursue this in another manner, I might try some of this stuff, but I probably would think about going to a different process. Add some anti-aliasing filters to improve the signal-to-noise ratio. Implement windowing. I was going to start getting into that, but then I got distracted into something else. Maybe it was my operation. This was all happening around the same time. And reduce the draw, update overhead, simpler GUI, fewer bars, all that kind of stuff. Maybe that might help. And use an this I don't know about. I just picked it up from somewhere. Use an interrupt time sampling instead of the slow analog read, and that might help improve things. So last thoughts. Well, we definitely are taxing the ability of the nano. Again, I put this all together quickly with not really too much thought. But really, I know it's not sensitive enough. It could be better. Expand the range to go higher than the 4 kilohertz, and develop this into a fully functional audio analyzer. And it certainly would fill a gap in the test gear that's on my bench. And that's pretty much all I have on this part. If somebody's interested in what the code I've done here, I'll just kind of quickly go through it for those that are interested in what was going on. I won't go through this line by line, obviously. You can kind of see where the gain control is about halfway down. Go for that. Then you're at the top, we're going into the FFT stuff. And on the bars halfway down on the screen. And oh, there's where we're going. Sorry. And that's it. Okay.
Yeah. So Dave's got a question for you. Go ahead.
Oh, morning, Dave. I mean, good afternoon, Dave.
Hey, Peter. Peter, did you think about using Audacity in your PC?
No, of course not. It'd be too simple.
Yeah.
No, I didn't, Dave. I was just, like I said, I was reading an article and then I was sitting in the shack and saying, geez, I got all this stuff pretty much. Let's throw something together. That's why I went down this path.
Yeah, a couple things about this system is that, it's an ADC, and so it needs a bit of meat to grab onto. So if you've got signals that are really weak, that ADC may not pick it up. You may have to put a front end amplifier in front of it to, boost it up. Whereas with Audacity, your sound card takes care of all that for you, right?
Yeah. Well, you know what? That might be a worthwhile thing to look into for sure.
That's it.
Okay. Thanks, Dave. Yeah, I'm sure there's a couple more than one way to, like in this hobby, to skin the cat. But in this case, like I said, it was one of those things where you're reading something and you recognize you got all this stuff sitting in your junk box, not doing anything. So you throw it together. That's kind of really the genesis of this particular project. Although I did eventually go out and order a different screen. Ken.
Is that your code? Is that the code from the article?
You mean versus AI? Yes.
Yeah. It came from the article?
Yeah.
Okay. No, just curious.
Yeah. No. This is before I even thought of AI. I think stuff. But this is just like I said. One of those Saturday afternoon, Sunday afternoons. You're reading the stuff, and you think, oh, I can do that. There might be some changes in the code, but basically the outline of the whole code is not. It's probably like 95% the article.
Yeah. Cool.
Charlie.
Great. Thanks.
Or Dave was up next, I guess.
Dave was first. Yep.
Yeah, Peter, I forgot to say, good job, man. Like tackling a software project, doing coding. Good job, man. I love it.
Thanks,
Keep it up.
Yeah, I kind of wished I presented it when I first did it because I knew exactly what I was doing at the time. But for what it's worth, here we are.
No, but it's good. Good job.
Thank you. Charlie.
Probably so.
We're going to turn you into a software guy yet, Peter.
Oh,
I just wanted to mention that Color TFT. There's some pretty cost-effective ones out there. There was one in the processor DCO board that was like $2.79, right?
Oh.
That's full color.
Oh, okay. I didn't know that. Thank you for mentioning that. Because when this project started off cheap because I had all the parts on hand, all of a sudden when you start looking at the modification, now you're kind of hooked and you think, okay, how can I improve this? And you start thinking, okay, I can do this, I can do that. And you look at this and you look at that and you start adding it up, and you know what? You're starting to push a few dollars for sure. Michael.
Just to point out that when I built the audio amplifier, there's one of the outputs is set up. One of them for the speaker, but the other one is a separate output for basically the audio spectrum analyzer. So you could be able to run that. Be able once that gets set up. If I had one, I guess I would try it on the audio amp and see how it works. Yeah. Anyway, that's all.
There you go, Michael. There's the schematic.
Yeah, right. This is right after I build Charlie's process. Let's see, Charlie's processor board, Kevin's power supply, Wayne's filter boards, and the superhead. Yes, right.
A project that never ends.
Yeah, right. Nothing ever ends. But at least I got the thing working today. Okay.
It's called relaxing retirement, Michael.
Yep.
Relaxing retirement.
Yeah.
Sorry. Go ahead, Michael. Yeah.
Oh, I was just going to say I've never been busier since I retired.
Right.
Yeah.
I have a question for you, Peter. What's the frequency range for the analyzer?
This one was 1 to 4 kilohertz. If you wanted to go higher, you definitely would have to go to another processor than the Nano. Matter of fact, some people, I don't know who now, I can't remember, they were surprised I could even get what I had done with the Nano on this one. But then, as Dave knows, it's amazing what you can push these controllers to do, because Dave found out at 4 Days in May there that I think it was Hans from QRP Labs didn't believe Dave could do I think it was Riddy with an Arduino, but he proved him. So, you know what? Try. You never know.
And it goes, sorry, down to 1 kilohertz or 1 hertz?
Well, the bar graph's 0, but I really don't know how accurate it is down below. I never gave it a full test, right?
Right.
Because this is the only thing I have that measures audio. So there you go. Kevin.
Right.
Yes. Sorry. No, actually, we were just talking about testing, and it's like, I'm just curious, did you take the waveform generator or something and go through and see how accurate it was, or was there any bleed through in the bins, or?
No, all I did was for the demo, I just played, I think it was a little bit of rock music and saw that. I thought, yay, it works. I'm happy. Another presentation on the books. That's the only thing I did with it. And then I got distracted with the other stuff. But I'd like to come back to it, although to Dave's point, the sound card Audacity, a lot of the heavy lifting's already done for you. So why reinvent the wheel? But
do you have that code available? Like, did you put it anywhere, or?
I probably do. Yeah. Oh, well, yeah, I do. I mean, there it is. There.
So you put a copy. Do you mind? I actually have something in mind, and since you've done most of the work.
Sure. Yeah. I'll. If you don't see anything in the next day, give me a text.
Okay. Yeah, if you don't mind, that would be great. Thanks.
Don't mind at all. Dave.
Yeah, I was going to answer Eric's question about the frequency, lowest frequency. Eric, with these FFTs, as Kevin just said about the bin size, what happens, you have to look at your sample rate. So on an Arduino can only sample, I think, at 9,000 times a second or 10,000 times a second. So with Nyquist, it means the maximum frequency is down around, 4 to 5 kilohertz, right? And depends on how much data you collect for how long. And there's something called FFT bin size. So what it is, it's the resolution to say, okay, right. each of those bars represents like 10 hertz or 100 hertz. So it all depends on how much data you're taking in, and the frequency at which you're sampling is going to tell you what your resolution is. So, you're not going to see, you're probably not going to see 5 hertz. You'll probably see a bin from 0 to say 100 hertz or 0 to 50 hertz. And that's the only, you're only going to get a resolution of 50 hertz. Does that make sense?
Yeah, it makes sense. It's going to have to go lower than 4 or 5 kilohertz though, right? I mean, it was showing down to 1 kilohertz on the, so.
Yeah, but look at each one of those bar graphs is a bin.
Is 100 hertz or whatever, right?
Oh yeah, or 50 hertz. I don't know what it is. You got to work out the math, right?
Looks like there's about 32 bins there.
Yeah, so you take 4 kilohertz divide by 30, that's your bin size, roughly, right? So that's your resolution. If you want to get more resolution, you have to sample higher, or you got to take more samples.
Right, and the Nano has a hard limit on that.
Yes, it's I believe it's 9 kilohertz, 9 or 10 kilohertz for if you're doing the full 10-bit sample, and if you drop it down to 8-bit sample, I think it goes up to, I don't know, in the teens of kilosamples a second.
Yeah, it looks like each bin's about 130 hertz.
Yep, it's not quite 10 per kilohertz.
And that's why I said this. Yeah. If I wanted to go more than 4 kilohertz, you need another processor.
Whereas with your sound card's typically, what's it, 96K or 48K it's sampling at. So if you're resolving a 4K signal and you're sampling it at 96K, you're going to take it right down to probably single hertz, right?
Yeah.
Okay, Michael, you had a question?
Yeah, about the bin size. So I gather the size of the bin is the resolution in hertz of the sample that you can take, right?
Yeah.
That's what it is.
As was just pointed out, take the 4 kilohertz and divide it by 30. I counted the bins up there. It's actually 32 bins.
Okay, and yeah, so that
works out to about 130 hertz per bin.
Okay, fine. I have to think about that, but all right, thanks.
So, Michael, what that means is that if you've got an audio signal at 5 hertz, right, and then another audio signal at 50 hertz, you're not going to be able to resolve it. It's just going to show as one bar.
Okay, got it. Yeah.
Or it could be like 100. What was the bin size you said, Peter? 100 and something hertz?
About
130.
130. So if you've got something at 200 hertz and 210 hertz, it's going to get absorbed into one bin.
Yeah. Okay.
Like you take that first bin that you can see on the screen now, that very first one there. That's 0 to 130 hertz.
Mm-hmm.
All the frequencies in that range. The next one, the big tall one, is everything from 131 hertz up to 260 hertz.
Got it. Okay. Very neat.
Well, nobody said any specs, but you get what you get, okay?
Okay.
All right.
But Peter, like I said, this was a great project for you to tackle. You learn a lot from it. And it's a good software project too, because you're learning about FFTs.
Yes, that's right. Okay, is that it for the? Okay, move on to the next one.
Yeah.
Okay. See if that's working. Yeah. Okay. Everybody see that?
Yep. Looks good.
So I'm not sure how I got going down this particular path, but for whatever reason, I decided to leverage Kevin's series on cool chips. I didn't think he would mind too much, and but I thought I'd take a different approach to it. And instead of searching through the data sheets and new products that come out and for looking for those really cool chips, I thought, why not take a step back and look at something that's that we kind of use every day. So that's what I did, and I came up for this particular one. I think the NE602/SA612 was an obvious and fitting choice for at least the first time out. And again, this one I put together probably back in, you know what, I don't even remember. Maybe it was the end of last year, the beginning of this year, somewhere on that day. Or maybe when I came home from the hospital, I started to feel better, and I did a splurge on some presentations. And that's probably when I did this one. So I may have forgotten a little bit. So bear with me. Okay, the NE602 and 612 SA612 chips are essentially the same device. Both are Gilbert cell double balanced mixers with an on-chip oscillator and a buffer. And functionally, for most hobby and RF projects, they can be treated as interchangeable. Now, the main differences that you might encounter are not in the core circuit, but it's really in the manufacturer, its branding, your packaging options, temperature ratings, that kind of thing, maybe some minor data sheet wording, or even the test conditions. And that's pretty much it. So your takeaways from that is simple. Don't overthink the part number. You know, think of the 602 and 612 as the same family of chip coming from different manufacturers or production errors, but they basically have near identical behavior in real circuits. So I consider this a cool chip because of the large amount of practical and well-documented information available about it. And in addition, the 612 provides a simple and a hands-on way to explore RF mixing concepts by experimenting with it in straightforward circuits. And in the background there is just an example. That's a very good sheet on the, just about covers anything and everything you'd want to know about the 602 chip. But there's lots of other information out there as well, as we probably all, most of us know anyway. Okay, the 612 addressed several common design challenges. It replaced diode ring mixers, remember the LBS days, and eliminated the need for external transformers, and its internal biasing greatly simplifies circuit design. And as a result, it makes experimentation far easier and more accessible. A Gilbert cell mixer works by mathematically multiplying the RF signal by the local oscillator signal. And this multiplication process is what creates new frequencies rather than just passing the original ones through. Inside the cell, differential transistor pairs are used to steer the current back and forth. And as the LO changes polarity, it switches that current path, and effectively it chops the RF signal at the LO rate. And because of this multiplication, the output does not just contain the original RF or LO. It contains new frequency components, which are the sum of RF and LO and the difference of the RF and LO. The circuit is double balanced, meaning that both the RF and the LO are applied in a balanced, symmetrical way. And this symmetry causes the original RF and LO signals to cancel at the output, giving good isolation and a cleaner mixed signal. Now, in practice, there is some leakage. And there's a simple line diagram of a 602 in use. And the pinout. A little bit of gotchas. The 612 is not a low noise mixer. Its noise figure is typically around 5 dB, which is fine for many projects, but it may not be ideal for very weak signal or high performance receivers. The dynamic range is limited. This means it can only handle a certain range of signal strengths before performance starts to degrade. It's easy to overload with strong input signals, such as nearby transmitters, broadcast stations, or large signals at the input that can quickly push it into, well, distortion or compression. The LO can leak into other parts of the circuit, and this leakage can show up as spurs or unwanted signals, so careful PCB layouts, short leads, and good grounding are important, as it is with pretty much everything we do. Despite these limitations, in many amateur radio projects, simple transceivers, these trade-offs are more than acceptable. The chip is inexpensive, easy to use, very well documented, making it a great learning and experimentation tool, even if it's not a high-end solution. And just a point about the documentation, it's actually, you know, you get a lot of chips there with it's got a lot of good documentation in it, but try to understand it. Well, the 612 or 602 chips, it's pretty easy to understand their documentation. Just showing the mixer output in the time domain. Try and count the different frequencies in that one. That's, of course, is the frequency domain. So here I'm showing both the line diagram and the schematic for a DCR. And the schematic should look familiar to all of us. That's the Park DCR. And we can see just how easy it is. And you start off when you're designing your circuits. You do your line diagram, which is over on the left bottom, and then you work on each circuit as you progress through the chain. So the 602 and 612 are still relevant, even though it's obsolete, and for a few practical and some cultural reasons. First, there's a huge legacy of designs based on it. For decades, it appeared in QRP radios, simple transceivers, kits, magazine articles, textbooks, you name it. And that means there's an enormous amount of application notes, schematics, troubleshooting advice available. If someone wants to learn mixers or build a simple receiver, they can follow well-proven designs with very little guesswork. Second, it's an excellent teaching device. The chip exposes the core ideas of RF mixing, oscillators, and balanced circuits in a way that it's easy to experiment with. You can build a working receiver with only a handful of external parts and actually see how changing the bias, LO levels, or coupling affects the performance. Modern RFICs often hide this behavior behind complex internal blocks. Third, it is still physically available. Even though it's no longer manufactured, large numbers still exist as new, old stock poles and clones. Builders can still buy them cheaply, so all that old documentation is still useful. Fourth, its limitations are educational. The modest noise figure, limited dynamic range, and tendency to overload forces us to think about filtering, gain distribution, and signal levels. Those are exactly the skills you want to learn when getting into RF design, which of course is what we all want to do, right? And finally, it represents a sweet spot between discrete and highly integrated RF design. It replaces complicated diode ring mixers and transformers, but it still lets you see and influence what's happening. That makes it perfect for hobbyists, experimenters, and educators, even long after it disappeared from commercial production. So the takeaway, the 602 easily shows how RF mixing really works. Simple enough to breadboard, powerful teaching tool for hobbyists, and in my opinion, a truly cool chip. That's it.
So, Peter, I just came across an article in QST from February of 1988. It crossed my paths, and it was a direct conversion receiver called the Neophyte. I don't know if that name rings a bell for anyone or means anything, but yeah. Sorry, you've heard of it?
Mm-hmm. Yes.
Yeah.
Yep.
So, a Neophyte receiver was talked about in a 4 or 5 page article there, which looked interesting. I mean, the schematic does look very similar to both the one you just flashed up there as well as, I guess, our own SOAREX DCR, right? So
that one there.
Doesn't look like there's many variations on this circuit, in general. So, what is there any significant difference between a 602 and a 612?
No.
Interchangeable?
Yes.
Yeah, completely interchangeable.
Sweet.
Okay.
Yeah.
Same pinouts and everything.
Yep.
Same specs, same.
Virtually the
same
same specs. Like I
I
was
guess-
a bit earlier, the only main difference could be is just really the manufacturing, data sheet details, that kind of minor stuff. But packaging details. Maybe one manufacturer doesn't do an SMD version, for example, or whatever.
Right.
But no, as
But
far
for the
as
hobbyist,
we are concerned, as hobbyists or whatever, anything that is different between the two is negligible, or we would never notice it.
and are they both still in production?
No. It hasn't been. I think the 602 has been out of production for a really long time. It went out of production first because the factory burnt down, and I think somebody picked up the slack with the 612. I think that's what happened. But the 612 hasn't been produced for a long time as well. I don't know exactly when it ceased production, but there's a gazillion out there. Just check the AliExpresses of the world.
Right, but there's no like modern equivalent with the same pinouts or anything. No.
I don't know about the same pinout. You can find some mixer chips out there, but they won't be a drop-in.
Right.
Drop-in replacement, I should say. You'd probably also be switching into an SMD version, whereas these are dips that I'm talking about here.
Right. Okay.
So,
Ken, please.
Sure. Did a 612 or a 602 ever come in an SMD? I'm not sure. I've never really looked.
Might not have been in the same era. Ken.
Yeah. Whoever picked up the 602 rebranded it as 612. It's exactly the same chip. Exactly. And you can still, it became obsolete in 2023.
That recent. Okay.
Yeah. And you can still pick up the SMD version everywhere. You can even get it at Kits and Parts. He's got tons of them. Right. Last time I checked, he used them. You look at all the QRP radios that were built over the years, and I would say probably more than 95% of them are using that chip.
And that's to the point I brought up earlier on. That it's used everywhere, at least in our world.
Yeah.
And there's so much information out there. I mean, name another chip where you have this information as easily and understandable as the 12.
Yeah. But I can't remember which chip or which chips I remember reading back maybe last summer. There are equivalents to it, but they're not drop-in.
Yeah.
Maybe what I'll do is I'll see if I can find out what the article was.
Oh, that'd be a good follow-up. That'd be a good
Yeah.
follow-up, Ken.
Yeah. I'll see if I can find out what I was reading, and because I was doing a search for chips somewhere, and this one came up. Wasn't even, but that's what I came up with. Yeah,
Well,
that's it.
The 612 was a pretty handy thing to do. I'm always seem to be doing something off and on over the years with the 612 or the 602. And, I pop them out of a board that I've long since not used and pop them into another, a new one. Whereas if it was an SMD version, I could be kind of beat. But anyway.
Well, the convenience of the dip package is that, like, when I had tons of them for the kits, all I had to do was pull one in, put one in, check it, pull it out, put the next one in, check it.
Yeah.
That's the convenience. If you do it with the SMD version, then you have to use a converter board for that.
Yeah, but you're not going to do that.
No. But I do have converter boards and the SMD versions to plug into a dip pack socket.
Good.
Michael.
Peter, what was the name? What was that article about? Something about the SO2 S602. You had a slide that showed that. I just want to copy it down. Okay, using it. That's the one.
Imagine if you Googled using the NE602, it'll come up. I forget what the actual title of it is, but maybe that is the title. Using the NE602. Just do a Google on this stuff, and you'll eventually come across it, and others as well. It's a really, really good article. It pretty much covers off. I think there was one little item in there that it didn't cover off that we got interested in. I'm not sure if it was during the DCR days that something cropped up about it, but anyway, it's a good article for sure. So if you want to mess around with the 602 or the 612, this would be a good sheet to read up on.
Yeah, thanks for the presentation, Peter. It's very good.
You're welcome. There's Cherry.
Hey, Peter, both presentations are super good. Thanks, Peter.
Oh, you're welcome. I just came to a thought there, Eric, to your point when you're talking about that other that article on that. Did that intrigue you enough that you're going to build it?
Well, I mean, it's essentially the DCR, right?
Yeah.
Is it not?
I can't think of the schematic off the top of my head, so I can't really say so. I wouldn't be surprised.
Yeah, I mean, it's a 40 or 80 meter, depending on how you build it, DCR. And again, like just looking, a glance at the schematic looks pretty similar, but you never know. I mean, might be interesting. It's a 40-year-old design, so might be a little bit difficult to, get.
Well, you know what? I bet you all the parts are still available. You build it and pop out the 612 that you built in your DCR and put it into your new Neophyte. There you go. Done.
Right. Well, since I don't think I've even completed the DCR yet, make sure I put it in a socket.
You shouldn't have said that. Okay. Ken.
Yeah, Charlie and I just post links to the article so you can download it.
Oh, good. There you go, Michael. Any other questions, comments? Okay, I guess back to you, Eric. Thank you, guys.
Yeah, that's good. Yeah, no, thank you, Peter. Great topics and short, sweet, but
Well,
easily digestible. So appreciated.
well, I managed to get through it, the talking, so I guess I might be good to go for some more presentations. So I'll start filling out the blanks.
Yeah, that's great. That's good. Good. Okay. So I guess we will, since it's about 20 after 8, we got time for round table. Before we get into that, though, I did want to just bring up Field Day. Again, it's coming up the end of this month now that we're into June. So June 27th, 28th, technically, are the 2 dates for Field Day. So one and all are welcome to come up for just a few hours or even an overnight, whatever you want. Be having people up probably as early as Friday afternoon or evening to just get settled in and set up and whatever else. The event officially kicks off I believe 2 o'clock on Saturday Eastern Daylight. So, Ken.
Yeah, I just want to make people aware it's not just for Field Day. You don't have to come out there and operate Field Day. If you want to work on something, that's fine. If you want to test an antenna, that's fine. I think there's two things to this. This is number one. I love operating Field Day. Number two, it's a get together. Get everybody together so we can see face to face instead of doing it through Jitsi all the time.
Yep, and the weather's good, and it's a relaxing event. We've done it here many years, and happy to host. So, all right, so I'll just leave that out there. I'll post something just to formalize it in the groups. But beyond that, not really much to say other than there's plenty of opportunities to set up whatever you want to here in a in a nice environment. So. All right, so maybe we will get to the round table portion of the evening. So, Charlie, you are first on my screen clock here. So, what's going on in your next?
All right, just give me a second here to kind of get things turned on. My camera's slowly coming up. So I mentioned to a couple of folks, and when we were looking at the presentations of 4 days in May, Farhan was handing out copies of his Larkset board, which is it's a super het receiver, supposedly one of the most cost-effective that you can get, and a group of us up here have been building them over the course of the past few months. We get together I guess we've got together 3 times now, but every 2 months for a weekend to work on building it. I've 3D printed a case for mine. You can kind of see it here. The original version is a complete analog transceiver based on a varactor diode for tuning. We had lots of troubles with that, so we've actually designed a little board for it to put in place a digital display and that sort of thing. Replacing the varactor tuned oscillator, and then we also replaced the local oscillator, which gives us upper sideband as well as lower sideband, and so consequently that and I also had a little bit of cat control. We should be able to do FT8 with this thing by the fall, or some of the other digital modes. Inside, it's a fairly simple, straightforward board. I don't know just how much of that you can actually see, but all this stuff is open source, complete open source radio. All the circuit boards you can order from JLC PCB and so on and so forth. There have been lots of issues with it. We've done an awful lot of learning. It was presented by Farhan is, a very simple radio that you can build in an afternoon. We built them in 2 days, and none of them worked. And since then, it's been tweak this, twiddle that, fiddle here and there to get it going. But it's been quite a learning experience. And and Peter's challenge about 3D printing, 3D printed this case for the Lark set. So that'll be on my collection of ones I'll show when we get around to talking about that. That's it for me.
All right, very good. So at the moment, it's a recommended not buy by the sounds of it.
Well, it depends on what you want to do, right? For a club as a build where you've got some, first-time builders and some experienced builders and so on, yeah, probably not the right thing to do. But as for an individual, if you're trying to learn about this stuff, if you haven't done a super hat before and that kind of stuff, and I've learned a lot from doing it. It's receiver. We had a power outage here a few days ago that we were out for 8 or 10 hours, and so I fired this thing up on batteries, and man, it was an excellent receiver with no RF noise around. But the transmitter, I still haven't figured out how to get that going just yet. So it's got a ways to go before I would say, it's a good club project. At this point, it's a good project if you want to learn about how this stuff works.
Right. Yeah. Well, there you go. If it just worked, then how much would you learn, right? So
fair enough.
Yeah. Okay. Very good. Thanks very much for the update, Charlie. Peter, you got a comment?
Yeah, but I'm going to say, but for once, I wish the project would work the very first time out.
Very true. Okay. Cherry, you are up next. What is going on?
Can you see me now? Oh, okay. I'm not sure.
Yeah, it's off and on, but
Okay. So on my side, not much. For the past few weeks, I've been very busy at work, and nothing much. Only some reading. Some magazines and some books which I have acquired. A couple of Hamfest back. Still reading through, and nothing much right now. Yeah.
Any Hamfests coming up?
Yes, this this ask about a Hamfest, and I can tell all about it. This week there are two, in fact, Saturday and Sunday. One is at Grimsby, Ontario, and then another one at where was it? Forgot it. I think it's somewhere close to my place.
Kempville.
Kempville and Cambridge. Kempville, and the next one is at Cambridge. Saturday and Sunday is going to be a busy week. That's the update. Yeah, you asked the right question, Eric. Thanks.
Yeah. Cambridge that's the Central Ontario one, is it?
Yes, Central Ontario.
Yeah.
Yeah.
Right. In Ayr, or whatever the name of that village is. So
yeah, looks like I will miss the field day event because I'll be traveling back after my vacation at that time. Yeah.
You just have to stop in after the Hamfest. Show us all the stuff, all your loot.
Yeah, it's June 27 and 28. I will be traveling. That's what I was thinking. Yeah. In fact, I think I will reach only on the 28th evening. Yeah. So I will miss that.
Okay.
Yeah. That's the update. Thank you.
Okay. Very good. All right, Mr. Pedantic, Dave, you're up next.
Hey, I relish every chance I get to correct you because you're always
Air,
correcting
air.
me.
Yeah.
It's
How's
air.
this pronounced?
But
Air, just
it's
air,
air, as in air you breathe.
air.
Yeah, they
Not
have
air.
they have the Christmas train. Have you ever? They have the Christmas train coming through there around November, December. Really cool.
That's what you do for fun out that way? Okay.
Yeah, the entire it's pretty cool. The entire town comes out to watch the Christmas train go through. They got the cops there. They got the fire department there. It's pretty cool. And I haven't been arrested. Oh wait, this has been recording, right?
You expose yourself to the train?
Yeah.
How is that fairly close to Paris? Air?
Yeah, it's like literally like 15, 20 minutes away.
Oh, I didn't think it was that close. Okay.
Yeah, it's not far. So yeah, no, I've been working on my rockets. I don't know if you guys could see behind me. Can you see that rocket behind me there?
Yep.
Okay.
Let's see the flames.
Yeah, I've been working on that puppy, getting that puppy ready because I'm going up to Timmins in August. I'm a judge for Launch Canada. That's where all the universities in Canada, right across Canada, all the universities, the students compete in a competition there, and they go up, they fly up to like 100,000 feet, liquid fuel rockets. They fly all kinds of really cool stuff. It's up in Timmins. I'm kind of excited to go up there. So I might fly that rocket there. I don't know. We'll see. But that's kind of what I've been working on.
Putting any RF into your
RF? What's that?
You know, like for telemetry or whatever.
RF?
Come
What
on,
is
you're
that?
not combining your hobbies?
I don't know. That's like air.
Where's that?
Fine. I'll explain it to you after I finish my advanced qualification course. Okay.
Peter,
All right.
if that happens, you know we're going to have to take a beating, right?
110%. Watch out. All right, Ken.
Yes, sir.
What's up in Brampton?
First of all, air is AYR, not AIR.
Yes, I love that.
I love correcting.
How you pronounce it.
It's air. Anyways, yeah. So couple weekends ago, I was thinking about building a wire vertical, and instead of searching blogs and articles and this stuff, I decided to use Claude. And at work, we've got the Claude package, and the first thing I wanted to do was to build a 4-to-1 unknown. So I asked Claude, what should I use for a core for 100 watts or more? And of course, he comes up and says FT 240-43. And so I got on to, this is the big mistake, I got on to Amazon, and they had some, and I ordered one, and it was a piece of crap. It turned out it was a 240-31 mix, not a 43 mix. And I asked Claude, well, how can I test this? And just it said to wind 10 turns, try it on your LC meter, and give me the reading. And it came back as 30 microhenries. And Claude said, no, that's a 31 mix, not a 43. So I decided to get on to DigiKey, and I ordered a couple and did the same thing. And Claude says, that's right. And so it kept going on and on. Talking to Claude for like almost a solid week, and it turned into Claude designing a vertical for me, or a wire vertical. And there's a particular one called the Rybakov vertical. It's 25 feet wire with a 4-to-1 unknown, and so I'm basically going to give that a try. But Claude also suggested going up to 29. Now, when you go up to 29, that's the bottom scale where you have to switch to a 9-to-1 unknown. But Claude suggested just try with a 4-to-1. And to throw in the mix, instead of putting down counterpoises, I'm going to be using Faraday cloth or Faraday fabric. So Claude gave me lots of diagrams, how to lay it out, and how to do the onion, and how to do the wire antenna. So probably the next couple of weekends, I'm going to put one up in the backyard, just try it out and see how it works. And that's basically it.
Okay. Bring it to field day.
Well, yeah, that was my intention for field day. The only other antenna I have is a long wire, a random wire, and that would require loading down the mast without putting up supports of any kind. So I wanted to try a wire and see what happens. Basically, you don't. It's windy. Claude says you don't need to support it. But if the wind picks up and starts throwing that wire around, then it's probably better off supporting it. That's it.
All right. Sounds good. Thanks for that, Ken. Kevin, what is going on out your way?
Well, I've built Charlie's board for our backplane radio. I haven't had put power on it yet. So anyway, so I got started on all those boards. So that's good. And I'm trying to finish my multi-trap antenna that I started a while back, like a couple of years ago, I think. Anyway, so I was trying to tune that actually today, and I discovered that tuning a multi-trap antenna is not as easy as I first thought. So anyway, it's all good fun, right? Other than that, just enjoying the nice weather. Actually, that's why I was outside today, because it's like I need something to do outside. Okay, I'm going to tune that antenna. So that was my goal today, and didn't get done, but tomorrow's nice too, I hear.
I was learning all about the theory of multi-trap antennas at my first day of the advanced qualification course on Monday. So shouldn't be, well, whatever. I mean, I'm sure it's in practice more difficult than the theory, but
yeah, I mean, you can set up, whatever, cut the lengths, whatever you want, but then, how did you wind your toroids and the traps, and, if it's off a little bit, and what's the real impedance, and everything interacts, even if it's just a little bit. Anyway, so, yeah, like I said, it's just learning. It's one, theory is one thing, but how well you can execute the stuff and make it happen in real life is
and again, good enough, I guess, is sometimes the operative principle, right?
Well, I'm using it for my QMX, so I want it to be fairly well tuned, because there's no, I don't have a tuner for it, so it's got to be matched somewhat. So I'm trying to run a 20, 30, 40 multi-band, right? So we'll see.
Ideally, I guess the best solution is to have an antenna farm. So, yeah.
Yes. Except this is supposed to be portable.
Right. I suppose. Yeah. Okay. All right. Very good. Thanks very much for that update, Kevin. Michael, what's going on with you?
Yeah, as I was saying earlier at the beginning, the main thing I did this today and yesterday was figure out how to use Kevin's design for Kevin's diagram for running the signal generator and the scope together to do a frequency sweep of the audio amplifier. And I got that working today, this afternoon. Seems to work. Anyway, I got a nice looking display, the squiggly wires all over the place, lines all over the place. It seems to work. I ended up asking ChatGPT and also Claude about how to upload files to the signal generator and the scope, and how to get the files down and whatnot. And they're both pretty close. Like Claude at least mentioned XML files, which ChatGPT did not. But anyway, I did that, and so that's coming along. I showed. Let me turn my. Where is it here? Wayne and I were talking about these winder things, and Wayne kindly made one for me, so I don't have to do it myself, which I would find very difficult to do without a 3D printer, I would presume. But anyway, so I'm going to try that out later. What else was I going to say? Oh yes, I have to show. I have to show this. It's my 5-band DXCC certificate. Got it mounted and everything. So now I got to find a place to put it. And speaking of antennas and whatnot, we're going camping up at our road next week. I'm going to take my QCX with me, and I have a 40 meter. It's a 40 meter QCX, so I got a 40 meter elevated radial antenna that I'm going to take up that I tried last summer, and it worked. And speaking of matching, Kevin, I agree with that. You have to, like, the QCX doesn't have a tuner either. So I took care when I designed it and tested it and tuned it by adjusting the length of the radials to make sure that it's the SWR is pretty close to 1, and it works. So it seems to be fine. What else? Been doing some radio stuff, at least trying. There's a new for me the expedition in Macau, which is a Portuguese territory of China, and supposedly they're on the air. I can't. You look at Club Log and you can see people are talking to them, but nobody around here is yet. Anyway, so I'm hoping, and I think that's about it, really. So I'm going to do some more work.
How are you trying?
Sorry.
I'm curious. How are you trying to contact Macau?
Well, they are apparently CW and FT8. So
Okay.
the easy thing to do is FT8, and
Right.
I'm using the VolCap software to produce a chart. And what I do is I got one here. I use a PowerPoint presentation, PowerPoint to do it. I got the VolCap propagation circle diagram that shows the different probabilities, and I've got on that also I've got a table where I can check off if I actually happen to make a contact, which is questionable at this stage given what the propagation looks like. But I'm gonna FT8 is easier, of course, and FT8 then CW and then sideband, which is pretty hopeless, I think, right now. The other expedition that's out there this week is Lord Howe Island, which is off the coast, northeast coast of Australia. And I have one contact with them from 2001 on 20 sideband, so I'd like to get some more, but we'll see. That one I'm not so fussed about. I really want Macau because it'd be a new band, a new country for me, but they're few and far between. Anyway, so that's about it. I did think about, I haven't actually done this, but I did think about asking ChatGPT what it thought about cloud, and likewise the other way around, but I haven't actually done that. just out of curiosity. Anyway, that's about it for me.
Okay.
Yeah.
Sorry, what park did you say you're going to be at? It kind of cut out, or at least on my end, it dropped out.
I'm going to Earl Row, which is the
Earl
same
Row.
place that Ken goes to, and we're going to go there next week, and then be back home for a week, and then going back up again for another week. So hopefully the weather will be nice, and we've got some good spots.
That's in my neck of the woods. That's just 20 minutes from me here. So, yeah.
Oh, I guess it is. That's right. Yeah, you're south of there, of course. Yeah.
Yeah.
I'll be there at the end of July.
Oh yeah.
Enjoy the black flies.
Yeah, good point. I don't know. I think we've been up there before in June and haven't had black fly problems, so I don't know.
Oh, you might be okay. I was out camping the first 3 days of this week, and I actually left to come home this morning, and the flies were incredibly thick. You couldn't be outside; they were so bad.
Oh, really? Well, that'll be interesting. Hopefully, we haven't run into that problem yet. Maybe because of the time of year we're going. I don't know.
Yeah, and I was a little further north than you.
That's true too. Yeah.
Hey, Charlie, all I got to say is one thing. Just one thing. Shame on you. You should know better. Really? You going camping in May?
No, I left June 1st and returned June 3rd.
It's still May. It's May-ish, right?
Of course I know better, but you know, it was a kind of a neat place. There was a breeze blowing, so it wasn't too bad for the first couple of days.
Where was it, Charlie?
I went to Lake St. Peter, which is just kind of south of Algonquin a little bit.
Oh, okay.
A little north of Bancroft.
Oh, yeah.
All right. Ken, come on in.
Yeah, I've been going to Earl Row for like 10 years. Never had an insect problem whatsoever, not even mosquitoes. The worst situations are chipmunks that try to get into the coolers.
Well, you know the rule, though, for anybody that camps at Earl Row, that's a ham. There may be uninvited guests that show up just randomly, other hams. So just put you on notice, Michael. So we'll be looking for aerials.
No problem. Yeah. Oh, I was going to say, by the way, antenna-wise, I'm thinking of I have an 80-meter antenna, and we were talking about sort of tuning dipoles and whatnot. I have the 80-meter dipole, and I'm going to try hanging a 40-meter underneath it on with the same feed point, just using the same balun. And for me that means replacing all the 80-meter wire because it's old and corroded. So I'm going to try that at some point over the summer, maybe. Anyway, that's it.
Okay. Just make sure you have travel insurance before we show up. So trip insurance, whatever.
You mean I have to have the insurance and not you?
You never know. Both of us probably. All right. Thanks very much for that update, Peter. Sorry, Michael. Peter, you're up. You're up next. Other than cool chips and audio analyzers, what else have you been up to?
Well, I'm up to my neck in crystal filters. I didn't know I was going to be up to my neck. Well, I'm above. It's above my head. I've gone that far. I've never been in a hole this deep before, but I am. I was just finishing off the super hep board because I wasn't happy with the performance of the crystal filter. And I decided to work with Claude on this one. And away we went. And days and days and days and days of trying different. I learned a ton. There's no question about it. In the months, all that. And talking with Wayne as well, I decided to work on building a crystal filter development board, and to help design and fine-tune filters before you put them into your circuit. So I've not been able to get to any of the other boards for the backplate, although I did put the two buck converters in there and tested that all to make sure it works. But that's as far as I got until crystal filters took over my life. And speaking of AI, or I wanted to just bring up a couple of points that I learned. Everybody talks about how great Claude is, and I know Dave and others have said, be careful, question things, but sometimes you got to get caught yourself. And Claude was not as infallible as I thought it was, and so I got 2 points. So I say question pretty much every step along the way, especially if math is involved or concepts are involved, and especially if it's a gray area for yourself, and you get the facts from Claude or any AI, I guess, but question it and make sure that it's right. And the other point is, if something makes you go, huh, or it's a little bit out there, question it. When I was talking about crystal filters with Claude, comes back and says, oh yeah, this core is going to take like 162 turns on it. And I thought to myself, what? That seems a bit weird. But anyways, we carried on with it and went all through it. And it wasn't for about 5 days later that I was thinking about this in the back of my head. I queried it. I said, by the way, you mentioned 162 turns or whatever it was on this particular core. That seems a little bit out there to me. Well, you know what? You said you're right. It is wrong on I made a mistake. And I thought, bloody hell. But the good part out of it was it sent me down another path to a different core that outperforms what I was talking about originally. But it still illustrates the fact, if something makes you go, huh, question it. And it's the same thing with simple concepts. Of the latest one was on the difference between auto transformers and transformers, and Claude was a little bit off base when it was talking about on the number of turns and what it meant. And so I queried it, and then it comes back and says, sure enough, yeah, I made a mistake. You're right. First off, it asked me to explain my thought process. So I explained my thought process, and it came back and says, yeah, you're right. So there you go. So question. That's it for me, Dave. Eric.
Yeah. Well, I mean, I think that's consistent. I mean, I've mostly used Gemini, to be honest with you. And at the bottom of every page, when you're on Gemini, it says Gemini is AI and makes mistakes. Basically, don't count on it. I mean, I was actually using it for some pharmaceutical, pharmacological therapy stuff, and asking it some questions, and it was clearly incorrect. Not all the time, but certainly there were bits and pieces where I'm like, huh, like that makes no sense whatsoever. I didn't get into the challenging of it or whatever. I just chalked it up to the fact that I think that's seems to be consistent with everything that I've seen and everything that we've discussed here and everything that I'm sure we've all read about it, right? Is that somebody who's at least reasonably proficient in any field is going to find that there's errors on the internet, right? That's the bottom line, because that's all this is really just regurgitated, repackaged, albeit in a very cohesive way, internet data, right? So anyway, Ken, go ahead.
Yeah, you got to be careful. We use Claude at work. Actually, I'm using Claude for coding. I don't write any more code. I get Claude to do it. But you got to be careful, because Claude can take you down several rabbit holes. A couple of times it was taking me down, and I didn't really realize it until it was too late. And I said, wait, stop, back up to such and such and carry on. And of course it did it. And then I got my answers the way I wanted it. So you got to be careful.
Yep. It's like that old adage, right? Somebody's wrong on the internet, right? Well, this is it personified. Kevin, please.
Yeah, just to add to that too, I've been, and that's why I don't use it for things, because if I can just look something up in a book, I will, because I find I don't have to question it. And the few times I have used it, where there's math involved, Peter, I have found mistakes every time. Even if the equation may be correct, it still gets the math wrong, and they're often subtle errors. So I don't trust it to do math. I have this thing called a calculator, and it's far more accurate, in my opinion. But anyway, one man's opinion.
And the calculator's got built-in functions, so it'll do it for you.
Yeah, exactly. Yeah, like as long as you know the equation, you just got to plug in numbers. Don't ask AI to do it. I would not trust it, because you should check it anyway. And if you're going to check it, well, just do it yourself, right? So that's been my experience.
Yep. Okay, Al, what's up your end?
Oh, there I am. Yeah.
Yep.
Oh, not a heck of a lot, but I guess some good news. My basement and shack renovations got completed last week, so I'm slowly in the process of bringing all the equipment back in and setting things up. So pretty happy about that. And so running around today, checking SWRs and some antennas. I've got a bad HF antenna on my Corolla, so. Not sure what's going on there, but traced it to the whip of all things. So I've got to either fix that or go get another hamstick and screw that on. But and apart from that, not too much more to report. No, everything is within standard operating parameters and moving forward. So hopefully I'll be able to make some solder and wires over the next month and get back into the saddle. So that's pretty much it.
Okay, good stuff. Looking forward to hearing some projects getting back, cluttering up the bench, so to speak. So nice. Okay, thanks, Al. Drew, how are things out your way?
Well, spent most of the last month getting my boat ready to go in the water, which I got achieved this week. So that's been a big time consumer. It hasn't been looked after properly, so spent a lot of time doing that. But I have been playing with the idea of an RF measurement device that you could take on an antenna range and do some data logging with it. So I got into a chip in AD8318. I don't know. Does anyone have any experience with these things? AD8318.
So 8318, 80. Not ringing any bells with anyone?
No, it doesn't seem to. Anyways, it's got a dynamic range that takes it down to minus 65 dB. So I thought, well, that should be sensitive enough. And so I had Cloud write me some code for it. It makes a nice little web server out of an Arduino and does all the measurements and stuff. And that all works very well. Sadly, it seems to be deaf as a post. So I have to figure out now whether I've done something foolish to the chip or whether there's just a problem. But the idea behind it is flying this thing on a drone over HF antennas to get the vertical, get it away from the ground. Anyways, and so that's been an occupation. Other than that, I'm trying to build wind generators. We'll see how that works out.
So you're looking at like a field strength
Yes.
meter? Is that essentially? Yeah. But a drone mounted field
Well,
strength.
the idea would be to fly it around the range and see how it does.
Right. Huh. Okay. Interesting. Peter, come on in.
Yeah, I just did a quick look at DigiKey. Drew, that chip's not cheap. It's like $26, one of them.
Yeah. I bought the one that dies off at 440 megahertz. So it's not quite as expensive. I think it was $13 or $14 from Amazon. It comes in a little board.
Okay.
But
Now, what kind of a package is it? What kind of, because this one here looks like it's a 16. This is a chip that it's almost impossible to solder. What kind of package did that one come in?
Oh, it's on a package with an SMA connector.
Okay. I was going to say, you know what you could do for a lot cheaper, mind you, that would have been the 8307 chip.
Okay.
Which is probably, I don't know what it costs now. It might be in the $10 range or something. Well, I guess I could look it up while we're chatting. But in that one, I have a lot of experience with. Well, actually, the whole group here has, because that's what the the SNA is based on.
Okay.
But
Okay.
you've already bought that one, so go with what you know. But
Well, and the thing is, I've got to actually get it to it. They are known to a bit deaf, and I don't know why that would be when it's minus 65 dB is at the lowest part of its range, but it shows a constant value. It's 25 millivolts per dB or something. So it's showing right now it's reading at 2.3 volts, and the voltage decreases as the signal strength increases. Inverse, anyway. And right now it's reading. I'm not hearing anything, and I'm thinking, okay. So I have to actually dive deeper into that aspect of it. I spent more time where I should not have, which was building the whiz-bang little web interface thing. And I didn't pay attention to the nuts and bolts and get the silly thing working first beforehand. So my fault on that.
I'll be returning to breakfast pretty soon, Drew. Maybe next breakfast when we meet in 2 weeks is to bring all the stuff that you got there, because this is probably very similar to the 8307 chip, which is a great chip.
My bet is that it's probably not much different. Yes.
But I just took a look at the price of the 8307 chips today, and I just about croaked here. $32. You know
Oh,
what?
God.
When I first bought those chips when they first came out, they were like $7, $8, something like that. Now they're $32. You know what? I'm gonna go look at my old boards and desolder them and put them on the marketplace. Holy cow. Jeez, $32. I can't believe it. Okay.
Now, was that a package?
They were
or
all
just a
bought up
chip?
by NVIDIA.
Those were dip chips. They were dip 8s.
So you still had to solder them and make them useful.
Yeah, I actually no, there weren't. No, I bought the SMD ones. I think. You know what? I can't remember. I probably have both types. But anyway, I can't get over it. $32. Anyway.
Yeah,
these ICs are becoming an investment now, part of your portfolio.
Hard to imagine.
Should just socket everything from now on, right? You never know.
Yeah,
I see a yellow hand up there. Whose hand is that?
They're all SMD components.
It's
today.
Dave.
That's Dave. Dave, dive in.
Yep.
Yeah, Drew, what frequency ranges are you looking for?
Well, it's HF to 440, I think, is the range of the chip I bought.
Okay. Have you a couple suggestions? Use a up converter, down converter, and put it into like something like what the ESP can read in, because the ESP can give you R, SSI, and signal strength. That's option one. Option two, once you use a SDR dongle with a up converter.
Yeah, I'm using an Arduino, and I didn't think an Arduino would read an SDR.
No, it can't. But certainly you could put like a little Raspberry Pi or something like that, which can certainly read it. Right.
Well, I was going for the lightest possible load. I've already blown that budget because I don't think it's light anymore. I was trying to get it like really a small little package that could be lofted easily, and yeah, we're not there anymore. So
yeah, your best bet is to look at like a ESP32, which allows you to have a Wi-Fi connection or a Bluetooth connection to it. Plus,
I have that.
Plus,
I have that. No, it is running off an ESP32.
Yeah, so you could take the Wi-Fi and have a up converter to convert the HF to in the Wi-Fi range, and the ESP32 will take it. It'll see gibberish, but it'll say, "Hey, there's a signal here. It's of strength, blah blah blah." So you could try that. That might work.
Yeah. Yeah, I can do a direct voltage measurement right off the 808318. And that's, I really needed to dive back into that. I have abandoned the project for the last month, getting the boat in the water. And as summer goes on, I'm going to do this again and get it back into the nuts and bolts of it and see why it's not reading. Because I suspect it's something fairly simple that I failed to do. Remember, I'm kind of an appliance operator. I'm way out of my depth on this.
There was also, Drew, a while back when I was trying to test out an antenna at my house. I built I don't know what's not a cubicle quad. It's an antenna. It's a folded dipole. We have a folded section of an antenna,
Yeah.
and if you get that and you feed that into like a tiny SA or something like that, I had it mounted on a white cross. So I was walking around my backyard with a white cross.
How'd that go?
With the neighbors, right? But you could try and use something like that, because that chip, what are you going to use for an antenna? Because the antenna is going to be, it may not reflect the proper signal strength.
Yeah. Well, certainly the antenna that I was using, I tested it at around 430 megahertz with a small antenna on it, realizing that what I had connected to the chip wasn't going to be picking up a lot of HF, but with its supposed sensitivity, I thought I'd be okay. I've done something more fundamentally wrong here, I think.
If I find the article I based my measurements on, I'll forward it. I'll post it to SOAREX, because
excellent, thank you.
There was an article about building the antenna and how you kind of calibrate it and work backwards to say at this frequency you're going to get this much attenuation and blah blah blah. I'll try and pick it up to see if I can find it.
Well, I know that one of our members in the CAREX group quite correctly said, well, if you want to do that kind of measurement, you better have a bandpass filter on it. So I have actually bought a QRP Labs bandpass filter kit, and I will have to build that and insert it. Or, God knows what it's picking up, power lines and everything else.
What is that chip? What is the chip number again?
Alpha Delta 8318.
8318.
I got it off Amazon, and there's a $13 version that goes on a little board, and I think it's good up to 440 megahertz. No guarantee it works properly. I mean, it's Amazon, right? So
Yeah, it's probably a clone.
well, and that's just it. I mean, like I said, I haven't got into the nuts and bolts to actually see if the thing's working. I'm going through the same process now, trying to receive weather satellite images like I used to a year ago before the Americans killed all the NOAA satellites. And the wonderful software I've got running, you may recall I mentioned Docker at some point. I got all that running, got everything functioning, and I'm not getting any images. I'm getting little teases of maybe an image. And I'm thinking, okay, I can't get the SDR to actually tune in the local CBC FM station. So there is a problem somewhere more fundamentally, and I think I have the same problem here.
What
I love
voltage?
the software. I'm bad at the packages.
What voltage are you reading on the output?
2.3.
Well, something's overloaded in the front end, because when you look at the range from minus 55 all the way up to minus 25, those kinds of things, the maximum voltage is about 1.4 volts. So if you're reading over 2 volts, you're overloading it with something.
Well, my understanding is it shows 2.3 if it's not reading anything.
Well, if it's not reading anything, it should be way less, because if you're down at minus 65, you're down to about 0.5 volts.
Yeah. Well, this is again, you look up you go to our Dr. AI and ask it, and that chip, it's got an inverse relationship with the signal strength and the voltage output.
Well, look at it this way, Drew. At minus 45 dBm,
right?
That's when it's maxing out.
Okay.
So minus 45 dBm isn't all that, strong.
No, it's weak. Yeah.
So
weak.
I mean, that's a difference. So if you're reading 2.2, it tells me you're overloading the front.
Overloading it.
Shot.
Yeah. Well, and I have to kind of pull off. I have to separate the chip from the circuit, or I have to separate the board from the circuit it's in, and do some fundamental measurements with it. See if I can actually get it to react.
I'm sure we could cure it.
Yeah. If I start that way and build it back up again, I'll be okay. But I really didn't do that. I assembled the whole thing. Basically, this is how it should work. And so now it's take it apart and put it in a situation where it will work. And as you have observed many times, that's a different path.
Well, I played with the 8307 chip, which is very similar in functionality. And
Yes.
It's a great, it works great. Yeah, we'll get it done. We'll figure it out.
Yeah. Well, it's what I'm exploring. I mean, a lot of this is a very steep learning curve for me. I'm still chemical, not electrical.
We won't.
Anyways, that's all the news that's fit to print from this little shack.
Okay, thank you very much, Drew. Nice detailed update from you. And second last, I guess, is Howard. What's going on with you?
Well,
how's your T41?
Yeah, well, I put that aside because I had some success at the get together. So I've been meaning to try to fix that Heathkit HW9, the QRP rig. So that's
Right.
why we had some discussions about transistors. So still haven't figured that out yet. But that's what I've been working on. So no output power, but we'll get there.
Okay, very good. It makes me think of my HW 101 that I acquired last year.
Well, that's a
That's
tube
what it
one, isn't it?
The 101, yeah.
Yeah.
It's in,
this is solid state.
Yeah, it's yeah. This one's in a state of disrepair. That I guess it was at our Smith's Falls event last year that was donated to me. So, but
I'll buy it from you.
Anyway, sorry,
I'll buy it from you.
Buy it. You can have it.
Okay, have it
Oh,
field
my
day. I'll
goodness.
take it.
Yeah. It's, it hasn't seen the light of day since Smith's Falls, so you're welcome. Okay. Anyway, well, I think that is pretty much it for the round table. For myself, I've got a little care package that showed up in the mail to me. So it is a little kit of parts for a common emitter amplifier circuit. So to do some experiments and tinkering with. So I have not done anything with it as of yet. Life has gotten in the way. But the plan is I've got a camping trip coming up imminently. So I'll be bringing this along with me at whatever stage it is by that point in 2 or 3 weeks or so, and work on it there. I think I'll have lots of uninterrupted time to delve into it and bring my little tiny tools with me to investigate the.
So what
the
date do we
circuit.
put you down for a presentation?
Well, I guess that would be the
July?
mixer in July, right?
Okay,
Yeah,
good.
July 1st mixer.
I'm
Month from now.
putting it in ink now.
It's encoded. Nice. All right. Well, there you go. I've got a no way out now. So the other thing I wanted to mention to everybody here, since we've been talking about Linux as of late, and I think some people have been getting into it, I'll put it in the chat here, but I was just listening to the creator of this Linux distribution, KB1 Oscar India Quebec. Andy is his name, and he's created something called Andy's Ham Radio Linux. So it's basically a ham radio centric distribution that is based on Debian, and might be something if you've got a spare Raspberry Pi, because it runs on Raspbian or Raspberry Pi OS or whatever it's called these days, and any other bit of hardware, but has a lot of good packages in it that are ready to go, turnkey solution for your ham radio escapades. So something you might want to bookmark and check out when the time comes. So anyway, there you go. And that's about it from an RF point of view. The front burner for me right now is getting my ground vertical up in time for field day. That's the goal in the next 3 weeks, I guess, until field day arrives. So that's what I'll be keeping busy with. All right. So anyway, I think that is about it. We've all said our piece. So if there's any last questions or comments, please come in now. Otherwise, our next meeting is 2 weeks from today, which would make it the 17th of June. So, all right.
17th of
Okay,
June.
well,
Hi, Eric. I might
17th
be
of June.
Yeah, I might be away.
Oh, yeah?
I'll touch base with
Okay.
you. I think we might need some. We might need a presentation then for that meeting on the 18th. Let me just double check before we all go. June 7th. Yeah, right now we have nothing scheduled for June 17th, so I'm going to be away. I'll double check to make sure, but I think I'm going to be away the 17th and the 18th. So if somebody can step up with the presentation in there, that'd be great. That's it for me.
Okay. All right. Thank you very much, everybody. Nice meeting again, and we'll catch you in a couple weeks.
Yep. Good night. Thanks all.
Yeah.
Good night.
Good night, guys.
All right. 7-3 all.
Have a good night.